Yeah, these are definitely more complicated, but it's the same steps that we've been talking about. You've got to just follow this recipe. Really is just a 1, 2, 3, 4, 5 type of thing. So the first thing you want to do is factor the numerator and the denominator. So the numerator is I call it an a equals 1 type problem. You got to find two numbers that multiply to 8 but add up to 6. So that is x plus 4, x plus 2. On the bottom, you're going to use a GCF to factor first. So there's a 4 that goes into both, and that's x squared plus 3, like that. And there is actually no further that you can go on the bottom.
Really? Oh, is it because 3 is prime?
3 is prime and it's positive. It's this on the bottom would be considered sum of squares, which is prime.
Okay.
3 is prime, but if it were -3, there would still be we could still do a few things. So the first thing I suggest doing is determining the domain. And you really want to use the factored form. So you set the bottom equal to 0. So, but it's only the terms in x. Like you don't set the 4 equal to 0. You set the x squared plus 3 equal to 0. And when you try solving this, you get x squared equals -3. And there is no number that when you square it, such that when you square it, you get -3. So this has no restrictions, which is odd, but it has no restrictions.
Okay.
Actually makes me think that this is not, I mean, I don't want to say this, like, if for all the stuff we've been doing, it's an odd question because you generally want to show the ones that have vertical asymptotes. This one does not.
Yeah.
So it's sort of an exception to some of the ones we've been doing. So the second thing you would normally do is determine holes. And these are where factors in the numerator and denominator cancel. So they have to be exactly the same. Exactly the same. So there are no holes. All right. Is that okay so far?
Yeah, I get it.
Okay. And then the third thing you look for now is vertical asymptotes. And these are where the denominator equals 0. And this set there is no vertical asymptotes on this problem. Okay, because again, that x squared plus 3, the bottom is never equal to 0. You don't set the 4 equal to 0. So we're kind of, lose so far. Like we haven't found anything useful. But this is the order. This is the recipe. You really want to do it in this order. 4 are the horizontal asymptotes. And this is the case where the degree of the numerator equals the degree of the denominator. So if it's not clear what I mean by that, it's actually easiest to go back to the original form here to kind of get through this. So the degree of the numerator is 2 because of that 2 right there, and the degree of the denominator is also 2 because of that right there. It's the highest exponent on x. So like occasionally you'll see an instructor throw in something like 8 to the 34 power, but you ignore that because it's only on the x that you care about. So in this case, it's the ratio of the leading coefficients. So that's 1 over 4, whereas 1 in front of x squared, a 4 in front of x squared. And we can finally put something down on the graph. And I've mentioned this before, you really want to graph as you go. Okay, but if there's nothing to graph, there's nothing to do. So you put that line right there, that horizontal line, wherever you think it's reasonable, label it. And then I like to put some arrows on either side because we're going to connect them at a later time.
Okay.
Okay, so that's gets us up to, so we're up to 5 or 6. Let's go y-intercept first. The y-intercept is when x equals 0. Wait a second. Did I? Oh boy, I really messed up here. I apologize. Oh man, I knew there was something wrong. Okay, a little bit of starting over here. You actually can factor out a 4x out of the top and the bottom. So that changes this significantly. It does have an issue here. So we do have to make some changes. I apologize for that. So I don't know why. Yeah, but whatever. It's that's the issue. So there actually are domain restrictions here. So we can look at that. So let's start back here at the beginning. You factor out a 4 and an x. They both have x in it, so you get x plus 3 inside. So you set the bottom equal to 0. You set 4x equal to 0 and x plus 3 equal to 0. All right, and that does change our graph quite a bit. So x cannot be 0 and x cannot be -3. And so your domain is -infinity to -3, union -3 to 0, union 0 to infinity.
Okay.
So really, really important that you factor and factor correctly. All right. Thankfully, there are no holes because these terms, there's no cancellations. There's no place where x plus 4, x plus 2, x plus 3 are in the top and the bottom. So you don't have any holes in this problem. There are vertical asymptotes, and they really tend to correspond to the places in the domain. Okay, the domain restrictions are either holes or vertical asymptotes. So again, you're saying that 4x equal to 0 and that x plus 3 equal to 0, and you get x equals 0, x equals -3 as your two vertical asymptotes. All right, and those are the only changes thus far. So we've got one at 0, and we've got one at -3. And again, I like to put those arrows just to sort of give us some hope of where we're going to connect. Now here, Jane, here's how I figured out that there was a problem. So when you find the y-intercept, and nothing else changes, everything else is okay. When you go to find the y-intercept, you put x equals 0 in, and I saw right away, I said, oh, the bottom is 0, and that's bad, okay? Because if the bottom is 0, that means there's a vertical asymptote or a hole there. And so this one does not have, it has no y-intercept because there's a vertical asymptote at 0. It never crosses the y-axis because you end up getting 8 over 0, which is undefined. So if you make the same blunder that I did, you may say, oh, maybe I need to go back and factor again.
That makes sense.
Yeah. So 6 are the x-intercepts, and this is where you set the numerator equal to 0. It's best to go back to that factored form. So we had this factored form up here of x plus 4, x plus 2 on top, and you set that part equal to 0. So you're setting each of those equal to 0. So you get -4 and -2. So the actual solving isn't really all that bad. Okay. And we can go from here. I actually should have made this graph bigger. Let me do that. So now we're on to 7. So we in previous problems we had never quite got up to 7. So let me just get some. So 7 is to test points in each region. So there was one at 1/4, which I'm not doing quite to scale, 0, -3, and then it crossed at -2 and -4. Okay, so the idea is that there's really 3 regions, and I was darn it, let me maximize that. I know it's not that clear, but let me try to show you. There's a region to the left of this red line, in between the red lines, but you actually need to further break it up wherever you do a crossing, because you really need to know what happens left and right of those. And that's what's really hard about these, because as a student, you're like, what do I do? Now let me draw these arrows again, because they were they're pretty useful if you once we do the test points. So let's get, there's one there, one there. They're always at the asymptotes. They're not at these breakpoints, which I think is maybe somewhat confusing. Okay, so let's test x equals 1. Okay, so the reason I'm testing x equals 1 is because it's to the right of this first line here. Now, do you know if you're going to be allowed to use a calculator on this test quiz?
Yeah, I can.
Like a TI-83?
Like an 84.
84. Okay, cool. Let me show you something, because it's really going to help you here to do this. Let me pull out the graphing calculator, and I'll share my screen with that. All right, so if you're seeing my screen, I got a 83 up. It's essentially the same as yours. All right, so here's what I'm going to do. You probably haven't done this before, but watch this. I'm going to type the number 1. I'm going to store it STO, just a little arrow to X. Okay, and if you got yours out, I would recommend following along here. So what does that do? It puts the value of 1 in for X. If you've done any programming, X is a variable, and it says always make X 1. Okay, now the next thing I'm going to do is I'm actually going to go back to our original function, original rational function. I'm going to type it as x squared plus 6x plus 8. Okay, and I'm dividing it by 4x squared plus 12x. Now, the parentheses are needed in the numerator and the denominator. You have to have them there. You have to have them all the way around the numerator, all the way around the denominator, like I'm showing you there. Yeah. Okay. Now, when I hit enter, we get a number. Okay, we get 0.9375. All right, so I'm gonna write that down. And the reason we're doing this is because we're gonna reproduce this. We're gonna do this calculation a bunch of times, and that's when you go to the calculator. So let me go back to my other screen. This will try to make some sense of all this. So when x is 1, if you're seeing my screen, when x is 1, y is 0.9375. So it's right up here. Oops, right up here, roughly. And that means that these lines, these arrows connect here. All right. So now we need to test a point. Let me mark these regions: A, B, C, D, and E. We just did A. I know it's weird going backwards the letters, but that's what we're going to do. So B is in this region from -2 to 0. So let's test x equals -1. Okay. Now, if I go back to the calculator, I'm going to go back to that screen. Okay. This is the power of the calculator. If I go -1 and I store it to x and hit enter, and then if I hit second and then entry down here, second and then entry again. So what that does is it recalls the previous lines. Now I've already got that x squared plus 6x plus 8 up again. I don't have to re-enter it. Now there's other ways to do it. You could go put it in y1 and do an ask. It doesn't really matter. The point is you don't want to be typing this in manually. You want to be doing it this way.
Yeah.
Okay. And again, I would encourage you to do that. It will save you time in the long run because we have to test so many points here. So we're going to go back to the other screen. Okay. Minus 0.375. All right. And that is when x, that's down here. Okay. So you got to go from this arrow or this arrow up above here, but you got to get to this point. The only crossing is this one at -2. This is the only crossing. So the only possible way it could work is this way right here. Something like that. Now, in full disclosure, right, you could sit there and graph it and make sure it looks right. Okay, but this is how you would do it in that other sense. So now region, and we didn't test in C, which we should have done. So we should have tested like -2.5. Okay, so let me go to the graphing calculator, and I'm just going to do this on my own here, and then we'll get the number, but we should see that it's a positive number, and it is. It's positive 0.15. So that's, that's up here somewhere, and that's how we know it works in this, and I call it the snake region. And similarly, when you do the other ones, when you test the other points, you get something that looks like this. But again, if you're allowed to use your graphing calculator, which is why I'm asking you, you really don't have to do, I mean, you don't have to test points, but you should. Like if you had, when in the olden days, you have to do it by hand. That's how students had to do these problems.
So, okay, so he has an answer sheet on the back. So in the middle line, right, the one that's curved,
Yes.
it actually doesn't go past -2. So everything above -2 isn't there.
Really? Let me go
Yeah.
graph this thing. Well, it's a bad start to the lesson. This happens from time to time. All right, let me graph this. Let's see what we're graphing here. All right, well, your answer key is wrong. I'll show you why
Really?
here. Yeah, let me show you. I mean, I do make mistakes, but I always go to the computer. Computers generally don't make mistakes when you give them the right input. So here's the Desmos output, and you can see that it definitely snakes up like that. I just entered exactly what you were given from the beginning. So this looks like it was pulled. This looks like it was pulled from like a Khan Academy or some random worksheet on the internet. But more importantly,
I just sent you an email of like what it looks like, because
okay,
I actually did this as homework yesterday, and he expects it to look like that.
let me yeah, it looks like I got a screenshot of some YouTube stuff.
Oh wait.
Oh no, I'm sorry. No, that's sorry. That's some digital marketing person. Yeah, this is I mean, you can oh, okay. So here's what it is. The graph of the answer, their gridded responses on the answer are I don't want to explain this. Let me snip it in to explain. Yeah, I was like, why are you sending me something on my YouTube? I get a lot of weird stuff out there. Okay, let me do it differently. There it is. Okay. Yeah, this is the problem with just pulling stuff off the web. Okay, let me snip it in here. Let me go down further. All right, so what the issue is that there's a vertical asymptote at -3, and see how the gridded it's using 2. Every block is 2. So this
Yeah.
line actually really goes up. You just can't see it. See how this one over here also looks like it ends at 6. It really goes up forever. And same with this one. It's just so close that they can't print them. But you can actually see it does kind of come across and up like that. And that's consistent with this graph here. It's just that they like, it's like they just stop it right there rather than it going up forever. And it's because of the spacing on the grid.
Yeah, that makes sense.
I mean, this is a very low quality image, rather than, hey, here's what it looks like in the real world. So
yeah,
go ahead.
What I thought that looked weird was, if you look closely, the line goes above the asymptote.
Yes.
So it still goes above it, just doesn't show it.
Yeah. Now, I mentioned a few times it cannot cross the horizontal and vertical asymptotes. That's only true on the extremes. So, okay, and here's another example. See how this right here at the, I don't know, I'll put a red dot there. It looks like this one stops there, but it actually goes down forever.
Yeah.
It's just the resolution of this printout is just not very good. But more importantly is do you understand, could you replicate Could you replicate this on your own?
Yeah, I just have to memorize the steps pretty much. That's about it.
Yes, that's true. All right, so let's look at that next question, and I'll try real hard to not screw up here from the beginning because that was really bad. Let's see here. All right, so first thing is to factor the numerator and denominator. In the numerator, there's a 3 in each term, so I like to factor out the GCF first, and then factor it in terms of like if it's an a equal 1 or something else. The bottom is difference of squares. So that one does factor nicely, x minus 3, x plus 3. But the numerator does further factor. You're looking for two numbers that multiply to -6, but add up to +1. That's x plus 6, no, I'm sorry, that's not x plus 6. It's x plus 3, x plus 3, x minus 2. And this is one of those things that you might be looking out for on a test. There's probably going to be a problem where the factors cancel, like we have the x plus 3 and the x plus 3. That'll help guide your factoring. Like you should almost like tend towards that. Okay, so the first thing we're going to do is domain. You do not make any cancellations yet. I know it's tempting to say, all right, let's cross those out. Domain, you set the bottom equal to 0, x minus 3 equal to 0, x plus 3 equal to 0, and these are the restricted values. So x cannot be 3, and x cannot be -3. And so your domain is minus infinity minus 3, union minus 3, 3, union 3 to infinity.
Okay.
And that helps you because there's something going on at 3 and -3. So second thing you look for are holes. And these are the anywhere where the factors cancel. So now I will actually go back and I will cancel them. +3, and then you write the reduced form so that you can figure out where it is. But the hole is at x plus 3 equals 0 or at x equals -3. But the reduced form is 3x minus 2, the numerator over x minus 3. And we're going to work with the reduced form from here. To find the y value of the hole, you take the -3 and you plug it in for x in both spots. So you get 3 times -3 minus 2 for -3 minus 3. So that gives you -5 minus 15 over -6, or what is that? 5 halves, or 2.5, if you will. So that's your y value. And probably good to put that point in right away. -3, 2.5. So let's do that. And I say it this way. I like to make the hole really emphatic. Make it really clear that there's a hole there. Don't put a dot. Put a big hole. You might even overemphasize and say hole, just to really make it clear. Don't let your instructor be guessing about what you mean by that. Third thing we're going to do are vertical asymptotes. So we look at the reduced form. The reduced form is x minus 3 on the bottom, so you set that equal to 0. So there's a vertical asymptote at x equals 3. So you make that dashed line, x equals 3. Okay. And the arrows there. Fourth thing we're going to do are horizontal asymptotes. So you look at the degree of the numerator of the reduced form and the degree of the denominator in the reduced form. Grab that and bring that down. So the degree of the numerator is 1, the degree of the denominator is 1. Since the degree of the numerator and denominator are the same, it's the ratio of the leading coefficients, 3 over 1. So 3. So you want to draw that in, y equals 3. Again, arrows are probably a good thing to have there. Graph as you go. You'll probably be the only student doing that. Probably wait till a lot of other students wait till the end, then they don't
Yeah,
remember.
he does it in a completely different order than how we do it.
I'm sorry. Yeah, I know that's not good for you. If you think that this approach is better for you, you should use it. If you like
Oh,
the
it's
other
much
approach,
better.
okay, good
Yeah.
to hear. The next thing we'll find are y-intercepts. So the y-intercepts come from setting x equal to 0, and you use that reduced form again. I guess that's right up here. Use this reduced form. You could go back to the original form, but it's once you simplified something, sometimes it's more work to go back. So 3 times 0 minus 2 over 0 minus 3. And look, it didn't become division by 0. Thank goodness. Minus 6 over minus 3 is 2. Now, if you get a sign error here, and this does happen from time to time, you will have some issues with graphing because it won't look right. You're going to try to connect things that just can't connect. So that's another thing to look out for. But again, you've got your graphing calculator. You may want to graph it from the start and just have it sort of there by your side to be like, all right, yeah, that's right. I see that, so on. So number 6 is x-intercepts. You set the numerator equal to 0, and the numerator is x minus 2. So just the terms with x. Just the terms with x. So x equals 2 and y is 0. So another dot there on the graph. So we're looking pretty good here. Looking real good, actually. The next thing would be to test points. But if you got your graphing calculator and you do have a graph, you'll see that this up here connects, and then the whole connects to the y-intercept, connects to the x-intercept, and then the only place it can go is down and down. You probably can see that with your solution there as well.
Yeah, for this one, it'd be easier because it's just y equals x, right? Or no, the parent function.
It kind of is, but that's because the whole 1 over x. It's because the whole reduces this down, this x squared down to that. Like there's a lot here. Like for example, you might think, well, hey Matthew, why can't it be the one in blue? And I think that's a reasonable question. Do you see though that the one in blue has to cross the x-axis?
Yeah.
And we said the only x crossing is here at 2. So and it can't cross the vertical. So this is an impossibility, and that's why it's not there. Testing points leads you to that, but you're sort of stuck with which ones can connect on their own. All right. Do you have another problem you can send over, or do you want me to make one up?
Oh, I got one.
Okay.
I just sent it.
All right. Now, what's the format of your quiz? Is it how much
There's
time do you get?
There's only 2 questions, except
Okay.
I don't know which ones he's going to use.
Yeah, that's we've covered all the variations on this. So you don't have like, there's not going to be something that we haven't seen yet on this.
Yeah.
but
I'd hope not.
but it's like you're not going to get the same at all. But if you follow these steps, you will be successful. Yeah, it's just you've got to, it's on your own. It's on you to do here. So, all right. So the first thing is to factor. Okay, so in the numerator, I'll help here. X squared plus 2x minus 8. But could you now factor the denominator and then that part in the numerator for me, please? Let me know what you come up with.
Okay. Would the 2x factor out?
No. You're factoring a 2 out of everything in the top. And
Oh,
I already
okay.
did that. I already did that for you. I already factored out everything. Hopefully you're seeing my screen.
Yeah, I see it.
Okay. So I'm asking you to factor that in the top and then the bottom underneath.
So would it be 2 times parentheses x minus 2, close parentheses x plus 4 divided by x minus 2, and then x plus 1?
Like this?
Yeah.
Yeah. Now, this would help here. Do you see how there's matching in the top and the bottom? And that's
Yeah.
you should be on the lookout for it. Now, will that always happen? I mean, no, it could be not that case, but yeah, if you're aware of that, that will help. So that's perfect. Okay. Could you next tell me the domain of this?
Negative infinity to -2 in union with -2 to -1
Okay,
in
so
union with,
when you set this numerator, I'm sorry, the bottom equal to 0, it's x minus 2
oh,
equals
it's
0.
+2.
Yeah, and that shifts your domain.
So it'd be negative infinity to -1
Okay.
in union with -1 to +2 in union with 2 to positive infinity.
Good. Excellent. Okay. Second thing to figure out are holes. Okay, and you wanna probably focus in on this part over here on the left or center here. That's what you're going to use to figure out the holes. And so what I'm looking for is the x value, the x value and the y value of the hole. So whenever you've got the x value, let me know.
The x value would be 2, right?
Yes. And that's when you cancel. That's when you say, all right, I got the x, gone.
And then you set it equal to y, right? For the simplified equation.
Yeah, you can, and it's probably good to do that. It's 2 parentheses x plus 4 over x plus 1. To get your y value, you use that place where the hole is and plug it back in for x.
So would the y value be 6?
You said 6, so it's 2 times 2 plus 4 over 2
Oh,
plus
it's
1.
4.
Yeah, it looks like it's 4.
Yeah, I got it.
And I would graph that immediately. So make a nice emphatic hole there at 2, 4. Boom. It's nice when it's on it's kind of a standard position there. All right, third thing is vertical asymptotes. So use that reduced form. Let me know what you come up with for your vertical asymptote, please.
X equals -4.
You're setting the denominator equal to 0.
Oh, yeah. So x equals -2 or -1.
Yeah, and that's just, it's one of those things you're just gonna have to really do something to remember. But like I said, you could graph it too, and then you would, oh yeah, there it is. It's at -1. That'll help here. Horizontal asymptote is next. Again, you look at that reduced form. Give that a try, please.
Y equals 2.
Yes, y equals 2. So you can draw another dashed line there, label it, maybe some arrows. Okay. And then y-intercepts are next.
So I set all the x's to 0 for that, right?
Yes, both x is 0, or however many x's are.
So y would equal 8, so the point would be 0, 8.
Yep. So 0, 8, and barely got room. For that. And then 6 are the x-intercepts. There could be more than one. You're setting the numerator equal to 0. So that's you already told me that in a previous problem. It would be x equals -4. Kind of already had that labeled there too. So in terms of like how you're gonna graph it, like you have to connect the dots, even if they're one's a whole. So you're like, all right, those have to connect together. And it's like, well, I got to get to an asymptote. So the only one I can get to without crossing is down here. And then same thing as up here. If you've got your calculator and you've graphed it, then you can just do that. A little bit harder when there's only one point, but it's got to connect with an asymptote. Something like that.
I got it. All right. Yeah, it's just pretty much about memorizing the steps for me.
Yes. So what's your plan for that? How do you remember stuff that you have to, execute on, like for a vocabulary quiz or something in English? What would you do for that?
Well, I have the steps written down here. So it'd be, let's see. Find the domain first, and then holes, vertical asymptote, horizontal asymptote, then the y-intercept and the x. And then for the domain, you take the reduced form. So it'd be x minus.
Not the reduced.
Oh, not the fully reduced. Sorry.
Yeah, the factored form.
Yeah, the factored form.
Yeah.
You set both of those equal to 0. You get the x's. Then you do the negative infinity thing with the in the union. And then after that, you find the holes. So you check to see if anything cancels each other out. And if they do, then you get the x. So you get the x. So, okay. So when you factor it out, you get the x, right?
When you factor, whichever factor cancels is the hole. Tells you where the hole
Yeah.
is.
So the x value of the hole here would be x equals 2, right?
Yes. Yes. And
Do
that's
you
what
always have to check the y value?
you have to get the y value. Yes.
Yeah. Okay.
The hole is a place on the graph. And that's why I was showing it so like, well, like clearly like, hey, it's right there. There's my hole. You could even point to it. The last thing you want to do is like point to a filled in circle and say that's a hole, because it's not. It's kind of an oddity. I mean, it's like we don't even talk about what it means. You learn that in calculus, but you're not in calculus, so you don't have to worry about that. It's just you gotta make it clear what it is.
It's just a point on the graph, pretty much.
Yeah. Yeah, so you got to know the steps. You got to remember like y-intercepts are x equals to 0, x-intercepts are numerator equal to 0, vertical asymptotes are the denominator, but it's the reduced form, not the unreduced form. And that's why this progression, you kind of like, you kind of get to eliminate things that won't mess you up. So if you get rid of the holes, you won't somehow use a hole as a vertical asymptote. But if you don't do holes first, you might think there's a vertical asymptote and a hole there.
Yeah.
And that's why this order is the right way to do it, because it leads to that. We've skipped a couple of things, like we didn't get range, which I don't remember you asking for us to cover.
No, he doesn't need the range.
Yeah, I mean, other courses you do, and that's, there's a place to do it, but you don't need it at the moment. And testing points as well. So this is probably a good place for us to stop, Jadon. For future lessons, please just, you're choosing the time on the website. So whatever you want. And then, we'll obviously cover whatever you need, but I think you're going to do really well in your quiz. This is the kind of thing where if you just review it, tonight, and then maybe in the morning or once before class at lunchtime, you'll have it down. You'll have no problems.
Yeah, I'll probably do that. I have more questions here. I'm just gonna probably go through them.
Yeah, graph them. Use Desmos to graph them, and just look for the stuff that you're thinking of. Desmos does not graph holes. You have to actually put your cursor on the place where you think there's a hole. I don't remember if this one had it, and it'll say like undefined at the point, but you got to get right on it or you won't see it.
Okay.
All right, well, that is it for today. I will send you the notes here shortly, and I'll see you next time.
All right. Thank you so much.
You're welcome. Bye now.
Bye.